textbooks, I realized that they kind of left out this whole thing. So thanks. We're going to go ahead and just make our own section 4.8. And we're talking about integrating the exponential function. We sort of, I don't know, a long time ago we ran into a problem that had e in it, but we've not had any that was a little bit more complicated, like e to some other power other than x. So I'm going to put up here first, I think, two integrals that we can just add to our long list of integrals. And both of these have the exponential function. One of them is just plain old e to the x, and then the other is going to have a little bit more going on. So we'll start with e to the x. If you remember, the derivative of e to the x is e to the x. Well, it works the same with antiderivatives here. The integral of e to the x is also just e to the x plus c. Now, the other one is not going to use x, it's going to use u. And so, just so we're all on the same page here, u is some kind of function of x. It might be 2x. It might be x squared. There's something happening to the x. Now, when you integrate that, if you notice right here, it does just turn back into e to the u. But, this is another little part I'm going to point out, you have to make sure, as we always do, make sure du is in the integrand. If du is 2, then you got to put a 2 on the inside and 1/2 on the outside. So all of that will be the same. You just got to figure out what du is. So most of our problems today will involve some function of x. You're not going to have a whole lot with just e to the x. So let's try some. Today they are all indefinite integrals. And then I think tomorrow, no, not tomorrow, senior favorites, there's like 10 of you that are going to be gone. So maybe not until Thursday, when we do part 2 of this imaginary section, we'll do definite integrals, where there's actually numbers for a and b. Okie doke. So here's example 1. We are integrating e to the 2x dx. E to the 2x dx. Obviously, this would be classified as e to the u because it's not just x, it's 2x. And so I'll go out to the side here just like I usually do with u substitution. I'm saying that u is 2x here. You'll find that that's true on a lot of these problems. U is usually the exponent. Whatever is your exponent with e, most of the time, that's what u is. So that means du is 2 dx. I've got the u up there in the exponent. I need 2 dx. Don't worry about the e right here because in the next step, this just turns into e to the u power. So the e is not related to the du over here. You don't have a 2 for the du part, so I'll have to pull a 1/2 out front. And then that whole thing turns into 1/2. E, that kind of looks like a 4, but it's supposed to be a u. E to the u du. Now we just have to integrate e to the u power. And if you follow the formula from earlier, when you integrate e to the u, it's just e to the u. But you can probably go ahead and do it in this step. You always need to go back and put in what u equaled. So 1/2 e to the 2x plus c. That would be our answer for example 1. Again, most of the time, u ends up being what's in your exponent because that's how we integrate it, e to the u power. Okie doke. Let's try another one. Example 2, x cubed, we're integrating again, but it says x cubed times e to the x to the 4th power, whoa, dx. X cubed e to the x to the 4th dx. Again, most of the time when you've got e somewhere and it's to a power other than x, a lot of times that power is what u needs to equal. Now this is like I always say, if you try this out and it doesn't work, then just try something else. So we'll see what happens. Now du for that would be 4x cubed dx. Now we just have to start picking out everything that we have versus everything that we need. We have the x cubed, we have the dx, we don't have the 4. So there goes a 1/4 out front. And even though there's more in the integrand with this problem, this is still e to the u, and then all the rest of that stuff in green is du. So here again, I'll keep the 1/4 out front, but when I integrate e to the u, it's just e to the u. And I'll go ahead and put back in what u equaled. So 1/4 e to the x to the 4th plus c. Any questions so far? Not too bad. Let's keep on moving here. Okay, we got a little bit more going on with this one. Number 3, we're integrating e to the 2x all over the quantity 1 plus e to the 2x squared and then dx. Now, unless I think it's going to turn into a natural log integral, which I don't think we'll really have here since this has e, but unless you think it's going to be something like that, most of the time you don't like to have a fraction like this in your integrand. So what I'm going to do is I'm going to take this quantity and I'm going to move it up so that it's not a fraction anymore. So e to the 2x, you can just put that out front if you want. And when I move up that quantity, now it's to the -2nd power dx. You don't have to do that step first necessarily, but again, I always kind of think if I'm not going to need du over u, like I had with the natural log stuff, then I'm not really going to want that fraction. So I said earlier that a lot of times your exponent, you may not want to write this down yet, but I said a lot of times your exponent is the u. And so if I try that on this problem, I'm nowhere close to du. This means that this quantity right here with the dx, all of that just needs to be 2 dx. And there's a whole lot more going on right here than just 2. So I probably will need u substitution, but I'm thinking I don't want the 2x to be the u. Any other ideas about what u could equal? U is usually what's in parentheses or under a radical. Let's go back to that for a second and see if that will work. Letting u equal what's in parentheses or under a radical. Now, to take the derivative of this, got to switch gears. We're doing derivatives now. Derivative of 1 is 0. The derivative of e to the 2x, long time ago, you've got this somewhere in your notes. If you have e to the u, to take the derivative of that, it's e to the u times the derivative of u. I just wrote that as u prime. So the derivative of e to the 2x is e to the 2x, but I have to come back and multiply that by the derivative of 2x, which is just 2. Now, to make that look better, I may just put the 2 out front. I don't want to forget the dx. It's always there, but I like to put it down. Now, let's kind of sort through this. That is u. So in the next step, it should turn into u to the negative second power. But then I need all of that for du. I have the dx. I have e to the 2x, but I don't know where you want to put it here. I don't have the 2. And so I need to pull a 1/2 out front. Now we're getting somewhere. So this 1/2 can stay out front. And now it is u to the negative second du. And when you integrate this, you're not even going to be using the integrals that I gave you earlier. This just goes back to the power rule for integration. We're going to add 1 to our power, put our new power on bottom. Now I should probably make that look better. This negative sign can go out front or on top. Either way is fine with me. The only thing you're going to have on top here is a 1 because the 2 is on bottom and u to the negative first. I'm going to show a step here. That goes to the bottom and becomes u to the positive first. So by the time I plug back in what u was, I have to take 2 times u on bottom. So 2 times the quantity, 1 plus e to the 2x, and then plus c. That would be our answer for number 3. The integral had e in it, but it turns out to actually integrate. It wasn't just e to the u power. It went back to the power property. Okie doke. Any questions on number 3? All right. There's a few more here, but I don't think the next one should be quite as long. Example 4. Hang with me. They're all a little bit different. We're integrating e to the x times the quantity e to the x minus e to the negative x dx. All right. Now, on this problem, I'm noticing the e to the x out front, and I notice there's 2 e to the x's, or that's a negative x, on the inside of those parentheses. You're probably not going to want to let that equal u, because then du is going to have an e from that part and an e from that part, and you don't have 2 e's out here. You only have 1. And so I would probably try to maybe simplify this a little bit first, and it's possible that we could avoid u substitution if we can get this simplified. Now let's look here. e to the x times e to the x. Anytime you multiply with the same base, you add your exponents. It's like if I took x squared times x cubed, multiplying with the same base, you add your exponents. So keep the base of e, but then what is x plus x? 2x. That's going to become e to the 2x. Now I'll go ahead and put that minus sign down, and let me try the same thing with this part. Multiplying with the same base, I add my exponents. What is x plus negative x? 0. Now be careful. When you get the 0, at least for me, it's kind of tempting just to make all of it 0 back here. But this does not equal 0. What was anything to the 0 power? 1. So this really turns into e to the 2x minus 1 dx. That is still not integrated yet, but now this should be a little bit easier. So I know that you don't write this out when you actually do these problems, but you can think about integrating each part separately. Integrate e to the 2x with respect to x, and then subtract the integral of 1 with respect to x. Again, you don't have to show this step necessarily, but this right here will require a little bit of u substitution. I'm going to have to this is actually what we had on example 1 today. I'm going to let u equal 2x, so du is 2 dx. And I chose a pretty bad spot to write all of that because I'm going to have to put a 2 in here to get the du, which means I have to pull a 1/2 out front. Thank goodness for different colors. So this was all my u substitution work, but to get that 2, we're going to have to use a 1/2 in front. So now this is 1/2. And if you wanted to go ahead and integrate, you can. I'm just going to leave it like that for now. That's not going to require u substitution. So I'm going to leave that alone just because I haven't really integrated this part yet. Now I can put it all back together. The integral of e to the u is e to the u. So just keep the 1/2 in front. And when I integrate 1 with respect to x, I just get x. But don't forget it should have a minus in front. So 1/2 e to the 2x minus x plus c. Looks good, only a little bit of u substitution right there. Now there's 2 more, so stop me if you have any questions. Number 5, got a big old fraction here, e to the 5x plus 4 e to the x minus 3 all over e to the x dx. We've had a lot of problems like this in the past where there's a lot of terms on top but only a single term on bottom. Here's what I would do to simplify that. I know some of you like to write it where you bring that up to the top and make it negative. That works, but you can also just take each term on top and divide it by the term on bottom. I kind of like to do it this way because then you don't have to distribute. You're just simplifying right off the bat. Now, what if you look at this first part right here, e to the 5x divided by e to the x? What do we do with our exponents when we divide with the same base? We subtract. And what is 5x minus 1x? 4x. That becomes e to the 4x. I'm subtracting my exponents. Now for the part in the middle, you can think of those just crossing out. So that's just 4. And don't forget the minus. But for the last part, you can't really simplify. So I would leave the 3 and do go ahead and pull e to the negative x up to the top. Now we just have to integrate. So again, I'm showing each little step here. You may not have to show this part, but we're going to integrate that and that and that with respect to x. So let me just show you what that would look like. There we go. Now for the first part, anytime e is to a power other than x, most of the time that power is going to be your u. And then du is going to be 4 dx. So with this first part, you need a 4 in here, so we'll have to pull out a 1/4. All right, and that'll turn into 1/4 times the integral of e to the u du. I'll fix that up here in just a second. You can go ahead and integrate that part if you want. I haven't integrated yet though over here, so I'm going to leave that the way it is for just a second. And then come in here to the last part. I don't think the 3 is going to be necessary when we do the du and all that stuff. So if you wanted to pull that out front for just a minute, you can. But then it's not just e to the x, it's e to the negative x. So we should probably work this out too. If you let u equal negative x, du, forgot the negative, du is negative 1 dx. And so with this last part, you don't have the negative 1. Now what's the reciprocal of negative 1? Negative 1. So if you wanted to put a negative 1 right here, you could. Or if you just want to change that to a plus sign, that's pretty much what's going to happen. So I'm adding 3 times the integral of e to the u du. I'm writing out each little step here so we can see what's going on. Now let's go ahead and integrate. 1/4 e, the u over here was 4x, and I can go ahead and put that plus sign down. I was going to put plus c, but the c doesn't have to come until the very end. So that takes care of the first part, plus when I integrate 4 with respect to x, it's just 4x, and then plus 3 times e to the u over there, which was negative x plus c. I'm okay on these problems just leaving the negative exponent. If you wanted to make that positive, you could write this as 3 over e to the x. I'm not sure what the back of the book would do on something like that, but that's probably fine for now. Okie doke. So, last one here. Any questions on number 5? All right. Number 6, there it is. PowerPoint makes rational exponents look kind of weird. So make sure you know that this is the integral of e to the 2 over x power. So the 2 over x is an exponent. All over x squared and then dx. Okay, kind of like I mentioned on, I think it was number 3, We don't really like our integrand to be in fraction form like this unless you think it's going to be a natural log type of deal, but I don't think we're going to have that today. So you don't have to do this first, but I kind of like to move the x squared to the top, and you can put it in front if you want to, or in the back. But I'm going to go ahead and rewrite that as e to the 2 over x times x to the negative second dx. Okay, Mrs. Street said most of the time, if it's e to some power other than x, that power other than x is probably going to be the u. I don't really like how that looks, so let's maybe think of that as 2x to the negative first, because then it's a little bit easier to do the du part. When I take the derivative of this, pull the negative 1 out front, now it's negative 2x to the 1 less power. Now, usually I like to fix negative exponents, but because I have a negative exponent over here, I'm going to leave that the way it is. You've got the u right here, so all the rest of this needs to be du. You have x to the negative second, you have dx, but you don't have the negative 2. So reciprocal of that would be negative 1/2, and that's what I need to pull out front. And then this just turns into e to the u. All the rest of that stuff back there was du. So I'm going to go ahead and plug back in what u was. When I integrate e to the u, it's just e to the u plus c. I would go ahead and turn that power back into 2 over x instead of 2x to the negative first, but that would be it then for number 6. All right. Any questions about that? These were all indefinite integrals. Tomorrow we'll kind of do the same thing but with definite. And because I'm making up this section, this is not really in the book, I copied a page or two from a previous textbook for your assignment. So you can go